Okay, so that's the problem-solving process. Equations. Okay, we have two types of collisions.
Elastic and inelastic.
Mm-hmm. Elastic is what?
M1, V1 shot.
Elastic is bounces off of each other, yes.
So M1, V1, I, so like the maximum velocity.
Mm-hmm.
Let's see, initial velocity of the first object plus the mass and initial velocity of the second object equals maximum velocity of the final velocity of the first object plus the mass and final velocity.
Uh-huh. I have a fourth period class. Yes. And theory of knowledge. Mm-hmm. Okay, the inelastic one is very similar. In fact, the left side is exactly the same.
Mass per object, mass say.
Mm-hmm. M1, does everybody understand that that means mass of first object? VF means final velocity. Huh?
Okay.
Do you guys remember what potential energy was?
I can't even find it though.
It's gravity energy, right?
Now, what, mass times
Mass times G, what's G?
gravity and.
Gravitational acceleration, which is 10. 10 or 9.8.
Mass.
This one was weight, force gravity, times height. Which, how do you calculate the force gravity? mg. Anybody remember the kinetic energy formula?
Mass
Mass?
velocity squared.
Correct.
Alright, I'm reading terms. Sorry, guys.
Anybody remember the equation for work? We'll see if anybody else does. Maddie beat you to it, Iris. Sorry. Work equals force times distance. Iris, do you remember power?
Is it in my notes?
It might be. I think we had it.
Joule?
Work, that's work.
Oh. How many people?
Work over time.
Oh my, which goes, that's smart when you for activity. Oh my God. Swear this, this.
You're gonna blame Mr. Klein, not the other 6 students.
I'm sick, and then I'm not sick anymore, and then Mr. Clark popped on me, so now I think I'm getting sick.
Yeah.
Oh,
No, but
that's why I.
okay. Anybody need those? Okay.
Think Max needs those.
Yeah.
Also,
He can pause. So, it could be in thermal. We're not dealing with thermal, okay? So, energy is transformed between kinetic and potential. Momentum is conserved between multiple objects, right? With energy conservation, we're talking about a single object usually. Goes up, increases in potential, comes down, picks up speed and increases in kinetic, but loses potential. The total energy or the mechanical energy doesn't change, correct? What does it ask me in number 10? What do you guys think?
matter.
Energy can't be created or destroyed. You were probably taught that, right? Matt, same thing with mass, and I'm going to tell you that they're both wrong.
Okay.
And no, it can't be destroyed. It can be changed. Who's seen this equation? Who's famous for that? Einstein.
Criminal Minds, the nerd. What? I'm reading it.
Um, but it's originally from Einstein. Energy equals mass times speed of light squared.
Ah.
Speed of light is this.
3 times 10 to the 8th power.
Meters per second. That's what speed of light is. You don't really need to know it to answer this question. So, we teach you that energy can't be created or destroyed, and mass can't be created or destroyed. Matter is mass. Mass is a measure of how much matter there is. Okay. So, this is Einstein's famous equation. It actually tells us that energy can be transformed into mass.
Mass can be created.
Yes, nobody has ever created mass from energy.
But
Theoretically, it's possible. In a nuclear reaction, we do create energy from mass. We destroy mass and create energy. In a nuclear fission reaction, we would probably actually be turning energy into mass. No. Nothing. So, you're thinking a chemical reaction. Chemical reactions, the law of conservation of mass and the law of conservation of energy work. Okay? Energy is turned into energy. Mass remains.
That's injury.
Teacher. What's that like? So she's a teacher for a reason. I don't know. Hey, it's.
There it is. That's the correct way to spell it.
But she told me that, and I'm second guessing every time I read my entire
No, I just spelled it wrong. If it's spelled wrong, yeah, sorry, I do that.
life. So I'm not such teacher.
I spelled mass correctly. Okay. Does that kind of make sense? Okay. There's a question about science versus engineering versus none of the above. What is science? It's the study of how things work. What is engineering? It's building things, how to make things work and how to improve things for essentially for human use, but could be for pet use or whatever. Of how things work and why they work that way.
Test.
There's a question like that on this review, so there's yes, a question like it on the test. Well, it gives you three scenarios. One of them's a science scenario, one of them's an engineering.
How?
And any energy is building things, learning how to build them, engineering, how to build them better. Okay? Engineering is often applied science, taking what you learned in science and applying it. What's the third one? Could be neither.
Could be either.
Well, you got to figure that out. I don't guarantee you I gave you one of each. There's three options though.
It's
So if it's not one of the,
science, engineering,
yep,
like science and science and all.
no. And just life or something like that. Okay?
Back.
Can somebody read me the last question on that review sheet?
The energy of a system is often. Systems that will take. We get that piece of it.
Okay, so energy is described as a system's ability to do work. Anybody remember what work is equal to? What else is work equal to? Change in energy. So is the definition of energy the ability to do work a good definition? Why not? I said why I'm asking this is a debate. This is a debatable question that I want you guys to tell me what you think. I don't know what's going on. Let's stay focused. Reyes, what do you think? You don't think it's a good definition. Why not? Now you think it's a good definition? Why? Do you think that the ability to do work is a good definition for energy? Caleb, what do you think?
Ability, but it's. Trying to think how to say this. Basically, like let's say we have that ramp,
Uh-huh.
the work doesn't change, the force does, right?
Yeah.
I picture energy is something similar to that. It's kind of like you can't change the energy
Well, so the energy used is the same either way.
because the distance has increased.
So that would be the work.
Yeah.
So I think you just defended that it is a good definition. What do you think?
It's the change in energy, right?
Uh-huh.
So energy is a good definition for, because it the change. I say it's not a good explanation at all.
It's a great, but it's an incomplete definition. Yes, I actually really like this for when I'm teaching you guys a high school physics class. Energy is the ability to do work. The energy I have, I can use to do work. Even if I'm sitting here, my body is doing work pumping blood and things, right? If I think on the microscopic scale,
No, it's not.
there's also nerves set. Can I get presents back here? There's nerves sending electrical energy and things around my body. So yes, energy is the ability to do work. It is a great high school physics definition. Energy is a lot more complex because it also can be changed into mass. So it's maybe not a complete definition. Doesn't matter. You're 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 doing the beginning physics classes in college versus the advanced physics classes in high school, all the same stuff. Okay? So that you can get college credit for it so you don't have to do it twice. If you explain it,
Uh-huh.
2 points. It's not a two. You'd get one out of two. So what I need from you is to give me an opinion. State what's good about it, and if you think there's something that's incomplete, no. In a lot of cases, the energy of that is an incomplete definition, okay? So, I would like you for the rest of the class to work on this review sheet. I will have answer keys for you to check it on Monday. Okay? I will answer any questions about the review sheet before the test on Monday. If you don't look at your physics between now and Monday, you probably not a great way to do well on the test.